For this lesson, we are going to be graphing quadratic functions. And you'll notice that we're going to be also comparing it to the parent function, which is f of x is equal to x squared. So you will notice that each one of these has a table of values. And what we do is we just substitute in these numbers into our equation in order to get the points so we can graph them. So f of x is equal to x squared is done for you. If you have a -2, we see that it's positive 4. If you put in a -1 for x squared, the answer is a 1. A 0, you get a 0. And then notice, if you put in a 1, you get a positive 1 for 1 squared. If you put in a 2 for 2 squared, you get a 4. The negative and -2, -1, and 1 and 2, notice their values do match. And that is when we're working with a quadratic function where you have the variable that is squared. So this is the parent function. And we're going to be making comparisons to this parent function. So on each one of my graphs, I already have the parent function there. But we will definitely be graphing the function that is given to us. So notice, for number 1, we have g of x is equal to x squared plus 6. So when I put a -2 into this equation, -2 times -2 is a positive 4 plus 6 is a 10. A -1 squared is 1 plus 6 is 7. If we put a 0 in, we see that we just get a 6. Putting a 1 in there, again, 1 plus 6 is 7. And a 2 squared is 4 plus 6 is 10. And again, these values should definitely match on your chart as you're doing it. So now we're going to go ahead and we're going to graph what this function would look like. So if x is a -2, our y is a 10. So I'm going up here and notice there it is. Okay, if x is a -1, y is a 7, going up to where my 7 is, moving over 1, and there we have it. If x is a 0, y is a 6. There's our vertex for our parabola. These are called parabolas. If x is a 1, y is a 7. And if you notice, here's 1. See how this point is just 1 away from the, this is called our axis of symmetry. And there it is. And then x is a 2. Right here, we're 2 away from, notice 2 away from, and there you go. So I mentioned the term axis of symmetry. That is this dotted line that goes ahead and it cuts the parabola. The quadratic function is called a parabola into 2 equal parts. So when you graph this, I know you're going to want to possibly make it a V, but it's supposed to be rounded at the end. And you do the best you can with that. So if I'm making a comparison from this to here, you'll notice they really are the same width, but this goes up 6. It's what we call translated up 6. So how does it compare to the parent function? It goes up 6. That's the comparison to the parent function, which is in the blue. All right, well, let's look at the next one. I have a -x squared minus 1. So I'm going to, again, put in my -2 squared here, but I'm going to write something so you can see what I'm really talking about. So here is my opposite of x squared, and this is a -2 squared minus 1. So when I do that, I get a positive 4. But guess what? That is a positive 4, but this sign is waiting, And so it's a -4 minus 1. And for a -2, we end up with a -5. So when I put a 1 in there, 1 squared is 1. But remember, this is now the opposite of what happens here. So we end up with a -2. We put a 0 in. Of course, it's a -1. And then I could go ahead and do the math, which I will, but no, you'll see that we will get the exact same things for the 1 and for the 2. So if I put a 1 in here, 1 squared is 1, -1 minus 1 is, when we're looking at our 1, you get a -2. And we're talking about a positive 2 here. 2 squared is 4. Well, that negative sign's waiting, so it's -4 minus 1 is a -5. And I don't want you to be confused. This was actually our answer for our 2. I just showed the work that was there. All right, well, let's graph this. If x is a -2, y was a -5. So here we have a -2, and I'm going down to -5, making sure I'm going over 2, and there's my first point. If x is a -1, y is a -2. So here's my -1 going down to, and there it is. If x is a 0, our y is a -1. So here's 0, -1. And if x is a 1, notice here it is. We go to our x is a 1, and we have a -2. Sorry, I didn't say it. And if x is a 2, which is right here, we're going, this is over 2, this is over 2. I'm putting my point there. So again, looks like you want to put a v there, but no, this is a parabola. So this parabola, notice, goes the opposite direction. When you have a negative sign in front of your x squared, you are going to have a, I call it a frown. It's going to be going downward. And this one I considered a positive. Positives make me smile, so that's how I remember that it does go up. So what happened between the parent and our new parabola? We can see that we have a reflection, and that reflection is over the x-axis. Whoops, x-axis. And then notice it also does shift down 1. So it goes down 1. You can have more than one thing happen to your parent function. So this one actually had 2 things going on. All right, let's look at the last one. Notice now, for the first ones, we did not have a coefficient in front of the x squared. We just, here we had a negative sign. Well, now we have 3x squared minus 9. And we're going to make a comparison to this parent function that's f of x is equal to x squared. So when I go ahead and I put a -2 here, -2 times -2 is +4. 4 times 3 is 12, and 12 minus 9 is 3. Okay, I'm putting in a -1 there. -1 squared is just a 1. 3 times 1 is 3. So 3 minus 9 is a -6. Putting a 0 in, you get a -9. And I've proved to you this other 2 times that I can just copy what I end up having here for my 1. So I'm going to put my -6, and I'm going to, for my 2, I'm going to put my 3. We've shown that that pattern really does happen. Okay, so now let's graph this. If I have a -2, I'm going up 3 for y. 1, 2, 3, and there it is. If I have a -1, I am going to -6. 1, 2, 3, 4, 5, 6. If I have x is a 0, Our y is a -9, which is all the way down here. For our 1, we end up with a -6. So here is a 1, and I'm going down to my -6. And here's my 2. And from at this point, you should see that we're going to go up 1, 2, 3. And there it is. Okay, so now I'm going to draw and it's called a parabola, quadratic function. And mine didn't end up being too curved. It's kind of hard to do this with a marker. When you're using a pencil and you can kind of sketch it, it's a little bit easier. But notice, since we have this 3 in front of our x squared, it's gotten skinnier, hasn't it? And so we call that a stretch. It has a stretch. And the stretch, it's a stretch of 3. It has gotten steeper. Okay, so now here is my parent function, and look at where the vertex is of the parabola, and it has gone down 9. So in this video, we not only have just graphed our quadratic functions, we've compared it to the parent function, and when we're making that comparison here, we call that really translations in our coordinate plane of quadratic functions. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.